Hey everyone, so today's our last official lesson for stats, and we're going to talk about some common distributions, and this has to do a lot with histograms. So the first one we're going to talk about is called a normal distribution. This is a bell-shaped distribution, so we can see a picture of it right here. It's a bell-shaped distribution that is symmetrical about the mean. So what does that mean here? If I drew a dotted line right here down the center, this right here is our mean. Whatever this value is on our x-axis, depending on the data that you're using, that's the mean, that's the average. And whatever distance this is, so these little dashes here, this is telling you your standard deviation, which is what we worked on last week. That's one standard deviation higher and lower than the mean, and this would be another of the same length, a second standard deviation, and so forth. And it tells you how your data is distributed, and if it's normal, that means it's all symmetrical, so things fall evenly around that average. So let's take a look at some data. So example 1 says, Sam recorded the heights of people who came into the BCHS main office over a school day. This data can be found in the table below. So you can pause the video and graph it and then check your answer, but I'm not going to do the graphing on here. You know how to graph by now. Some things I do want to talk about though are these brackets here. So right here you have a square bracket. That means that this number is included in the interval. So remember when we said that when we do histograms, we're talking about ranges of data, not just specific numbers. And how do we show that? And how do we know where to put our data? Well, anything that's from 130 up until 140, but not including, so 139.9, cool. Once you get to 140 though, it goes into the next category. So this square bracket tells you it is included, and this round bracket tells you not included. Everything up until super close 13 or 130.99999 works. 140 though, no, goes into the category below. So we call that not included. So square bracket, yes. Round bracket, no. And we have a frequency table, so we can put it into a graph. Hopefully you tried it out on your own, but this is what our graph ends up looking like. Remembering that you have to label your axes with like height in our units here, and we also have our frequency on the y-axis, and you're labeling, you're putting a scale, and we also have a title. So check, 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 and check here, which is great. So if we take a look at this graph here, that's our histogram. It looks great. It looks like it's normal. It kind of looks like this shape here, but we want to check for sure. So this instruction below says place a point at the center of the top of each bar and join the points with a smooth curve. So let's try it. I'm going to zoom in a bit and we will try it. So I'll put a point in the middle, in the middle, in the middle. There we go. And you want to do this every time. So if you continue with the next two examples on your own, this is exactly what we're going to be doing. So once we do that, we can try to connect it with a smooth curve. And you can see here that this resembles that normal distribution. So what do we notice about this? It's a normal distribution. These heights tend to fall around a mean, and that is a common thing. If we measured the heights of students in our class, if we had a chance to do this in school, we probably would have gotten something very, very similar to this normal distribution. But now we want to take a look and see what other kinds of distributions can be made from data. Do they have a name for it? So with our next example here, a civics teacher recorded the Unit 1 test marks as percentages of her Period 4 class. Display the data in a histogram, place a point at the center as we did. So this data has already been graphed. We have our mark percent at the bottom, frequency on the y-axis. Notice how with our scale on the bottom, even though these here are listed as intervals, we don't have to put the intervals on here. That naturally is 40 to 50 up here, goes in between 40 to 50 down here. So that is how you graph. And so we'll place a dot at the center of each bar here, and then we will connect it, and we'll see that this one makes a funky shape, and it ends up having these two peaks, we'll call them. So that's what's different about the shape of this graph. It has two peaks versus that normal, which had one that was in the center. These are two peaks that are kind of split up evenly along the graph. The shape of this graph is described as bimodal. It means it has two equally likely measures of central tendency. And so basically it says it basically means that there are two modes, two intervals that have the most number of, or the higher frequency. So this type of graph here, if you ever see a graph with two peaks and you have to identify it, the word that you want to use is bimodal. And finally, we have one more example. I think you should try it on your own. Pause the video and then come back and see if you did it right. So as we go forward, example 3 says students recorded their final marks in their grade 11 math class. Oh, that's us. These aren't real. This isn't your marks, don't worry. So display this data in a histogram. We have title, marks, frequency, scale. It has been recorded here. So even though this first one has a 0 value, you just kind of do a single horizontal line at the 0. We still have to put a dot in the middle of that bar. So we have a dot here, 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 and then we connect it. And it has one peak, so we can't call it bimodal, but it's definitely not in the center. So when it has this shape, one peak, but not in the center, it's either shifted to the right, like this one, or shifted to the left. There are cases where it might look like more like this. So most of the data falls to the right, or in this case, most of the data falls to the left of the mean. We call this skewed. A skewed distribution is a not symmetrical distribution of data. So there you go. You have 3 new types of distributions that you should be able to identify. That's the point of this. You need to be getting good at making histograms. Now you have to understand putting these dots and drawing the distribution and then identify what type it is. So I'll post some practice questions and hopefully this helps. See you later.